Welcome back. Last video from your Term 2 work. One more topic involving U substitution stuff. This is again a slight variation on U substitutions called change of variables. And this method that I'm about to show you is useful when we're doing a U substitution with roots, when a U substitution doesn't completely take care of everything. This method is particularly useful with roots. Shows up other times, but we're just going to focus on the roots. Especially when a U substitution doesn't completely take care of everything. This method I'm about to show you is useful with roots, especially when a U substitution doesn't completely take care of everything. I'm going to show you 3 examples, and that should do it. For our first example, I want to do the integral of x times the square root of x plus 4 dx. If you were trying to do a U substitution, I want you to tell me the U, the du, and what problem we have. U should be your inside piece. U is x plus 4. Du, derivative of that thing, dx. What's wrong? What's wrong is you have this extra x out front. Here's how I can deal with this. Well, first of all, I know that this thing over here, this is u. This thing over here is du. I've got this extra thing to deal with. I can do what's called a change of variables. I'd like to take this u equals x plus 4 equation, and I want to solve it for x. Really, just subtract 4 from both sides, and you can make the little equation x equals u minus 4. Well, because of that, I can replace my x with u minus 4. If you chose to replace this x with u minus 4, you'd get u minus 4 plus 4, just u, which is what I said in the beginning. Rewriting this problem, I now get the integral of u minus 4 times the square root of u du. And the point is, this substitution let me move my sum that was underneath the root into something outside the root, actually a difference outside the root. And even though this still looks ugly, it's actually going to be a lot better. Because now I can use some algebra to rewrite this. I can distribute the u to the 1/2, and I can make this the integral of u to the 3/2 minus 4 u to the 1/2 du. I'm just distributing a u to the 1/2 to both of those pieces. I think you can probably finish this up. Go do your integration, and when you're done, replace the u with the x's we had in the original problem. Okay, so u to the 5/2 over 5/2 minus 4u to the 3/2 over 3/2 plus a constant. I'm going to clean that up and make it 2/5 u to the 5/2 minus 8/3 u to the 3/2 plus c. And then I'm just going to go and replace the u with what it stood for. This is going to equal 2/5 times x plus 4 to the 5/2 minus 8/3 times x plus 4 to the 3/2 plus a constant. I'm going to make the video pause so you can finish making any notes. Again, this method is called change of variables, particularly useful when there are roots in the problem. We try U substitution, and it doesn't quite take care of everything. I have 2 more examples I want to show you. Let's try this one. Let's do the integral of 2x minus 1 over the square root of x plus 3 dx. What's u and what's du? I'm going to make u the thing that's underneath my root, the inside function. I'm going to make u x plus 3 its derivative du, just dx, which means all this stuff up top is extra stuff that's going to be a problem. I'm going to go chop, so let me label things. I've got my u under there, I've got my du over there. Let me go solve this thing for x. I'm going to get x equals u minus 3. I can now plug that in. This is the integral of 2 times u minus 3 minus 1 over the square root of u du. Let me distribute and clean things up top. Integral of 2u minus 6 minus 1 over the square root of u du, or I can say the integral of 2u minus 7 over the square root of u du. What you can do to clean this up is you can separate your fraction. I'm going to make this the integral of 2u over u to the 1/2 minus 7 over u to the 1/2 du. By laws of exponents, this becomes the integral of 2u to the 1/2 minus 7u to the negative 1/2 du. Please finish. Okay, so let's see here. 2u to the 3/2 over 3/2 minus 7u to the 1/2 over 1/2 plus a constant. That's 4/3 u to the 3/2 minus 14 u to the 1/2 plus a constant. 4/3 times x plus 3 to the 3/2 minus 14 times x plus 3 to the 1/2 plus a constant c. I'm going to make this pause so you can write anything down that you need to. Okay, I hope this works. I'm trying to do some editing with this video because I just went through this last example, and as I looked up on the screen, discovered that none of it was actually on the screen. You couldn't actually see anything. So hopefully this will work this time, and hopefully I can splice the two things together. Last problem we're going to look at, and this is about as tough as they're going to get, and I'm going to try to throw everything I possibly can into this one problem. I want to do the integral from 0 to 4 of x over the square root of 2x plus 1 dx. Use substitution, change a variable, definite integral. It has everything in it. Oh my goodness, my phone needs to stop buzzing. Okay, please tell me what u is and tell me what du is. I'm going to make u that inside piece, 2x plus 1. Du is the derivative of that, so 2 dx. I've got an x up top. I want a 2 dx. Well, I'm going to multiply inside by 2, maybe rather over there by 2, and outside to cancel it out by 1/2. I can now say that this thing is my du. I've got a u under my square root, that's good, but the x up top is going to be a problem. I need to do a change of variable. I need to go and solve this equation for x. I'm going to get u minus 1 equals 2x. Divide both sides by 2, x equals u minus 1 over 2. So, I am going to get the 1/2 out front times the integral. This x up top is now u minus 1 over 2. In the bottom, I have the square root of u. This thing outside, this 2 and this dx, together those make up my du. I need to change my limits of integration. Tell me what 0 becomes and tell me what 4 becomes, please. X equals 0 becomes u equals 2 times 0 plus 1, or 1. X equals 4 becomes u equals 2 times 4 plus 1, or 9. So I'm going to do that problem. Okay, I clearly have some cleaning up to do here. This is 1/2 times the integral from 1 to 9 of u minus 1 over 2 root u du. You know, this 2 in the denominator, I'm just going to move this up front. Not like move it up front, cancel things out by like multiplying by 2. No, I'm going to use my constant multiplier rule. Don't think use substitution, just think constant multiplier rule. Move this 2 that was in the denominator up front to get a 1/4 times the integral from 1 to 9 of u minus 1 over the square root of u du. Please take a moment, use some algebra, separate your fraction and clean up the thing inside the integral, please. I'm hoping you got that out of it. I think I want to see if you can finish this. I think you can. And remember, because it's a definite integral with a u substitution, once you get, you know what, don't bother finishing. Just get the antiderivative, then stop, then we'll talk. Hopefully you got that. I'd like to see if you can plug in 9 minus plug in 1 and send in your answer to Edpuzzle. To the 3 halves. Square root of 9 is 3, cubed is 27. Minus 2 times square root of 9 is 3. Clean it up in a moment. Over here I've got a 2/3 minus 2. Okay, so 2/3 of 27. 27 divided by 3 is 9, times 2 is 18. Minus 6. Minus 2/3 plus 2. This is 12 plus 2 is 14 minus 2/3. That's going to give me, oh my goodness, let me think. 42/3 minus 2/3. That's 40/3, which is going to give us 10/3. The area under this mess that we started with. What is that signed area? It's just 10/3. And that's all that I have to say. This is the end of Unit 7. We are basically at the end of Quarter 2. You are going to have a test on the second day that I see you, which is going to be, well, actually, either Tuesday, February 2nd if you're Cohort A, Thursday, February 4th if you're Cohort B. I will see both groups on Monday, February 1st, Cohort A in person, Cohort B through the computer, and we'll do a little bit of review then. Looking forward to seeing you soon. Take care.